I'm a hydrogeologist. For context, California would start about right there and head down, so that lets you at least know where Idaho is in comparison. And eastern Idaho, I also work out of the regional office, so at the same time, even though I speak for what's going on in my region, other things are happening within my state, and what I'm trying to do with my work is to present a means for others in the regions in my state to understand the sources of nitrates. The role that I have in my work is to understand the distribution of nitrates, the distribution of impacts to groundwater, and then communicate that to those that can do something about the particular issue with nitrates. So we've heard a lot about this, and it's very well established that the nitrates are a local issue. The sources are local, the impacts are local, and the jurisdiction that needs to deal with nitrates, if it's not a public water system or not a wastewater issue, that's local also. And but at the same time, we can see here that the expertise necessary to address that typically is not local. In our regions, there are 6 regions for our Department of Environmental Quality. I'm a hydrogeologist. 2 of the other regions have experienced hydrogeologists. Another has a person who is very good at what she does, and another region with very good at what they do. However, they don't have the background or the experience to be able to dive in here and deal with these issues. There's no guidelines. If the problem is big enough, Central Valley, California, Yakima Valley, there's going to be resources available for that. The researchers are here. You know, the people that I've been talking to and having a chance to talk to over the last few days, they're the folks I've looked for, and they're the work I've looked for to try to understand how to solve these problems. But again, when we deal with it at a state issue, that expertise doesn't exist in the same places. You know, that doesn't exist in all areas. In listening to how things are happening in California and how things are happening in other places, Idaho really has a lot going for it. About in the early 90s, our agencies that deal with water quality and agriculture and water quantity got together and determined that they needed to set a plan in order to address issues related to the usability of our groundwater. And part of that groundwater quality plan set up a structure so that data would be generated. For our Department of Water Resources, they manage the quantity, but they also look at water quality statewide. Our Department of Agriculture, they don't regulate nitrates, but they do regulate other things pertaining to agriculture. They regulate pesticides, they regulate feedlots and CAFOs. And our groundwater quality, the Department of Environmental Quality, we deal with, with point sources and deal with drinking water. But together, we put together a structure to collect the data. Now, with addressing these particular issues, just like it's primarily a local problem, when the issues are addressed, when there are issues, concerns come up, it's going to be addressed at the regional level. So the regional offices have to deal with it. But as we deal with it consistently across the region, the same objectives are there in place statewide. So our objectives for sampling are identifying really spatial distribution, where nitrates are occurring, and those objectives, as I go through the objectives, they do have some implications on how monitoring to address these concerns come up. So if we're trying to look at spatial distribution, that means that to do that, you have to have a statistically based means of identifying sites and collecting data. So we've heard about that from the USGS and their NAQA, a statistically based sampling method for selecting sites is necessary. The other thing that our Department of Environmental Quality is supposed to do is understand potential sources. You can't always get that with a statistically based. Sometimes you need to look where you know things are high, where you know there's a nitrate issue, you know there's a source. And so this regional monitoring sometimes requires a biased sampling instead of a statistically based sampling. Another specific objective, since we don't regulate what happens at private wells, we don't regulate what happens at the local level if it's not a public water system, then where we do have our impact is to work with those that do deal with the producers, that do deal with those that need to have a solution at a local level. So evaluating the effectiveness of best management practices for, let's say, nutrient management or other issues like that. So what we do is we provide information, collect the data, and the way we support things is to provide that direct education. I've talked to a few others. I'd love to do edible aquifer with the 5th and 6th graders. It's a great observation, a great way to let them connect with how the system works. We talk about a lack of scientific education. Well, a great thing to do is let's show them how the process works. But also, the decisions and the issues need to be directed, need to be taken care of at a regional or local jurisdiction. It's the cities and the counties that have the ability to create ordinances that govern whether or not they'll allow a dairy of a certain size in their county, or whether or not they will allow a certain limit to lot size that can have both an independent well and septic. Those are things that the local jurisdictions need to deal with. Got to provide them with the information to do so. And that's really where we come into play with regional monitoring. So I'm going to go through continue on through the flow chart. When we're looking at developing a monitoring program, and looking through the literature, there's a lot of work done on how to collect on the samples to collect, the data to look at, but I haven't seen a lot on how to design a monitoring program to accomplish that. So if we're looking for a source that's at the surface, that piece of conceptual information comes into play by letting you see that if we're looking for a surface source, then we need to look at monitoring close to that source. And so where we focus on domestic wells, those are more likely to be completed shallow. But also, since we don't want to look at a particular issue or try to address an issue that's actually located right next to the well, then good well construction is something that is of great concern if you're choosing sites. In Idaho, we have the benefit of having a database that has all the wells constructed since about 1980 online, so I can check the well logs. The other aspect of that, I know a good well, but also when I'm choosing wells for regional monitoring or local monitoring, I'll focus on domestic wells or livestock wells because those are more likely to be completed in that shallow zone. Some public water system wells may be, but industrial or bigger domestic well or public water system wells, they're likely to be completed over a much broader zone. Irrigation wells, I try to avoid those because the quantities being pumped are not representative, and the zone impacted isn't representative of what we're trying to look at. So regional and local. Regional, it makes a big difference to have this ability to do spatial interpretation from the data. Local, again, to be able to relate a source back to a signature, you need to know sometimes what's happening right there. And once you do that particular type of site selection design, then what you do at each well really remains the same. So as for a statistical design, we're trying to look at randomly selected sites, and based on that, we don't know what the nitrate levels are going to be, what the chemistry is going to be. That's why it allows us to do predictions. So statistically, the same sample, the process for doing statistical sample design is really the same whether you're doing it for a political survey or you're doing it to try to understand nitrate concentrations. And the terminology used are sampling frame. That's really for my application, it's a hydrogeology. It's the aquifer, it's the land use. The sampling unit is how I discretize that. How do I choose my site that I'm going to monitor across that particular area? So the sampling unit is a subset of the frame, and the sampling element is the well within that. After that's done, if I do have, data that's also randomly distributed based on a statistical sample model, and I have some kind of information what's going on, then it gives me a way to actually estimate how many sites I need. Again, the benefit in Idaho is there are two other programs that have collected the statistically based sampling. Also, in your particular area, if the NAQUA program is there, they may have that same basis of data to work from also. So if you have that information, then you can use that to tell you how many sites you need to collect and be able to come up with a statistical uncertainty about the data you receive, the results you receive. So here's an example. Here's what it looks like, the sampling frame. Here's one of my subareas. It's pretty clear. The hydrogeology is the same. The land use is the same. It's bounded by all these, half or quarter square mile center pivots. And what you also see from that are the sampling elements. The element is the square mile. In Idaho, and actually a lot of places in the U.S., we use the public land survey system. Person who was speaking about Wisconsin, they looked at the blocks. It's the same thing. It's square miles. It's how the whole United States was surveyed out. So it gives you a basis. What's important about that also is within that, I look for appropriate wells. In this model, since I do have seed data, pilot data from other monitoring programs, in this region, I used GIS, selected square miles that didn't have someone else's monitoring data in it, and so I selected a well out of that. You have the distribution, you have the structure, and then you have the ability to get a spatial estimate. The other value of this is since it's statistically unbiased, then I can take my population and the results from that and combine it with the other populations. So looking at local monitoring, this is biased. That means I know what I'm looking for. If I want to look for a site that's low or close to a boundary, I've biased that result, but it still tells me about potential signatures. So the same terminology really fits. Sampling frame, it's the area of interest. For here, it could be, in Idaho, we do what we call a nitrate priority area, so it's an area we know that has elevated nitrates. Or it could be a neighborhood, or it could be a county. Whatever unit seems to work, it's the area of interest. The sampling element within that is just the same as a sampling element within the random model. It's a well, so I'm looking for a well that fits my criteria. For this, instead of having a statistical model to tell me confidence, it's based on budget or time frame. The example I'm going to show in the next slide, I had just a certain amount of time and a certain amount of budget, so I chose wells that fit within that. So here's an example. Same thing. Here's a nitrate priority area. It's my area of interest, my sample frame. And the elements within that are all the wells. Some of the other monitoring programs had data from this that showed elevated nitrates, so I tried to choose some of those. It also had some of these public water wells, or the domestic wells, the smaller markers, and I chose wells with from that population that were close to the boundaries or where I had a lower data density. So again, here's an application of what the bias sample site looks like. Collect the sites and know where I'm going to sample. The methodology used is really the same methodology that other researchers have put out, this concept of a forensic sampling, nitrate sampling, or multi-tracer sampling. And the methods and analytes, that's things that these other researchers may know more about. But what I want to do is choose those specific analytes and digest it down so that others in my particular agency, they won't have to go through the research again. But you have some general conditions in what you're trying to accomplish with the monitoring. You're trying to understand first general groundwater quality and mixing conditions. Those tell you really where the water's coming from and give you some ideas about the impacts. Can be very difficult to pull out the signature for the sources, but if you understand the hydrogeologic context, it helps. The other group of analytes are those that specifically help you characterize nitrogen sources. There's a lot of things that can do that. Specific tracers, specific characteristic ratios. Choose your selection of isotopes, and we love isotopes, but we also know we have to have those with some additional data. Some other things that we look for that kind of help complement this group of analytes is things that tell us about the nitrogen cycle, about the biologic processes, so the dual isotope N15O18 and nitrate. Also things that tell us about the history of the water. That's the history of the nitrates, the history of the water. You can learn that from the tritium. You can learn that from oxygen deuterium, things that give you the date of the recharge. And then site conditions. We're limited in time, but I have lots of pictures of pretty nasty wells, and it really answers the question as to why there's a problem. But to put the chemistry and the isotopes in a real context, that's necessary if you're trying to do this at a practical way. Interpreting results, that's really where things come together. What I intend to do and what I'm working to do with this particular aspect is to provide some examples of what the signatures would look like. I've talked to a few others about Piper diagrams. We love that. These are some physical ways to show how the data come together. And what I have for this and the examples I will show you are some examples of how to interpret that. Characteristic sources, some characteristic plots, and also some things that help understand the biological processes. And then one of the last things I want to show is how you can look at the isotopes and get a history of the water too. So Piper diagram shows water chemistry, cations, anions. And what's interesting about this one is it shows really history of recharge sources. These are different places along the flow path. Here's an upper portion of the flow path. Here's a lower portion of the flow path. And in between is the mixed. And what I see from this are these sites that fall outside of those. The mixture of the recharge sources explains that characterization, that variation. Other things come into play with these. Here's another example. This one is nice and clear. That's typically not as clear as what you see here, but these are from the local source, the biosampling. Here I have a gradation in nitrate concentrations, but going along with that, you see this relative increase. Along with increase in nitrates, there's an increase in sulfate, and we see that very clearly in this trend. The other interesting thing is in this area, along with an increase in nitrates, there was an increase in calcium. So this particular area, high nitrates, sandy soils, raising potatoes, you add ammonium nitrate and ammonium-based fertilizers, you end up increasing soil pH. So what you need to do is you need the lime to reduce that. So here's a BMP, calcium carbonate added to lime the soil. I see that related to where where they're losing the nutrients. Not quite as clear, but still, here's N15 and nitrate, and one of these characteristic ratios, chloride to sulfate. You know, it takes a little bit more work to interpret that, but these sites up here with this high sulfate to chloride ratio, other indicators say this is a waste source. So it supports that. One piece doesn't answer all the questions. And this other piece of information, history of the nitrates, here's a history of the water. For this particular area, a collection of sampling, the green symbols here, for that area, where they plot on the local meteoric water line and where they plot within the region tells me that the recharge was primarily snowmelt. For another particular area, it's offset a little bit, but it lines up with a meteoric water line. That tells me that looks like the water flowing down the river that's used for recharge. So you can interpret that piece from it. Another piece with this, well, go back. Another piece we have some sample sites that follow along a groundwater recharge line. Just based on the physical processes that result in recharge, you have that characteristic slope. So I have some sites up here that tell me that the recharge is happening with irrigation, irrigated ag. Those pieces all fit together. So moving from that, you know, it's a work in progress. The things that are most interesting for me is I need to take a look at the data, and I need to be able to do a more in-depth review to try to optimize for local signatures. Principal component analysis, some of the other statistical methods. Another thing that seems to be missing from this is to be able to sample to tie directly to sources, trying to monitor soil underneath, say, a new best management practice. And another very important part, I have a few pictures. Here's doing the edible aquifer. But through all this, there are a lot of local, the issues are local, the problems are local, and the resources need to be local. So, any questions?
Thank you very much.
So you were talking about unbiased sampling and then combining it with other data sources. Is it pretty easy to figure out if your other data sources were sampled in an unbiased way, or were a lot of those targeted sampling studies themselves?
Well, we knew that they were specifically unbiased sampling because they were collected as part of this statewide groundwater monitor quality framework. And so I know that by design, one set was unbiased based on the statewide level because of the statistical design. The other one, just history of the sampling, I know that those sample sites were chosen based on the statistical measure. So yeah, knowing the background, knowing the history, you have to know that to know whether or not you can even work with the data.